Good morning. So we're going to work on using the distance formula, everybody. So with this, we're working on using the distance formula. So remember with this, we figured out, if you look at it, if we want to find the distance between A and B, so that's a slanted distance, okay, it's related to the Pythagorean theorem. Because if you look at it, so we're going to take, so this is the hypotenuse, AB is the hypotenuse. Okay, and then we have our base because it's all about that base, that base. No trouble. This is for our right triangles, everybody. So that it's going to be, so the distance between these is going to be our distance right here. And between our x coordinates. And then our distance so that's for our horizontal distance. And our vertical distance is going to be the distance between our y coordinates. Okay, so that actually, so they are related. So let's use an example, everybody. So let's say your school is 4 miles east and 1 mile south. Okay. So for me, I go, oh gosh, I have to remember my directions. So north, east, south, west. Okay. The recycling center where your class is going on the field trip is 2 miles east and 3 miles north of your apartment. Okay. So 2 miles east and 3 miles north. Okay, so it's going to be right here, recycling center. And so your apartment's right here. That's your apartment. And estimate the distance between them. Okay, so we're looking at this, everybody. So notice again, yes, we can use Pythagorean theorem. Okay, so we can use Pythagorean theorem for this, everybody. So it's going to be, so what I want to show you with Pythagorean theorem, get right on this, doesn't look right. Okay, so what we have is that it's, if we take the square root of each side, okay, we're going to get, so it's the vertical distance. So we're going to have C is equal to, or the distance between the recycling center and your school, okay, it's going to be our C value. And then we're going to substitute those all in. So we're going to, remember we go left to right. So everybody remember when we're doing this that we you do it left to right. So I'm encouraging you to graph these on decimals when you're doing this. So, and of course, label your points. Everybody label, label, label. Got to label them. So I'm going to label them. I'm going to substitute it back in to my distance formula. I'm going to write it out. Just remember, we always want to write it out. Write it at the top of your paper, just like we did with SOHCAHTOA and Pythagorean theorem. It helps us remember it. So then I'm going to substitute in my values. So I'm going to substitute in 2 minus 1. Sorry, 2 minus 4. I'll provide the right values. Plus 3 minus negative 1. So everybody keep track of those negatives. Okay, and then I'm going to take, and I'm going to do my keep change change. And on decimals, everybody, you can enter this all in onto decimals too, and it'll definitely work. So let me show how to put it into decimals. Okay. So see right here, everybody, that's the square root. I do my parentheses, okay? And then I'm going to do 2 minus 4. And then it goes squared plus parentheses 3 minus negative 1, parentheses squared. Okay, And so it gives us a value of 4 and 4,700. So remember 5 and up rounded up, everybody. So we're going to round that up to 4.5. I'll show you in the paper. I'm just going to go down here because we did on decimals. So remember we rounded to tens place, 5 and up rounded up. So you're about 4.5 miles, so 4 and 5/10 miles between the recycling center and your school. Okay, so everybody, so this is doing distance formula. I'm going to do a couple more examples. So, but if you feel comfortable, you can start working. You can also watch me just go over them. So I'm going to go over a couple of these. So this one's error analysis. So one thing, of course, everybody, so we always write the formula. So write the formula. So this is from our textbook 1.3. So write the formula out. So it's a square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Okay. So this one, I noticed right away, no square root. Okay, so no square root. She didn't do that. So the student didn't do that. And then what else do you think? Kind of giving you a hint here. So if you look at this, everybody, it's right here. Okay. It should be right here. It should be the first one, and it is the second one. Let's see if they did that with the next one. We'll use our Westwood colors. Nope. Put it as the second one. Do you see how it should be right here? It should be the first one. Okay, so they mix those up. Okay, so no radical, no square root sign. And put y in the wrong place. Okay, let's check the second student. Okay, so look at this one. So if you look at these, I go, okay, so that's 6 is x sub 1, 2 is y sub 1, 1 is x sub 2, and this one is y sub 2. Oh, so they didn't put the x values and the y values together. Got it. So they didn't put x and y values together. So they didn't put the change in y and the change of x together. Okay. So also notice you have to put the order on these two. Okay, so I was going to do this one. It has a baseball player. So I'll pull a match. Okay, so I'm going to skip to the next one. We do a baseball player. The picture didn't come out very well. Okay, so this one, let's look at the park. So let's say we're going to Pioneer Park or Riverview Park. So we're going to look at this. It says find the distance around the park. Okay, so everybody, if I want to do this, remember I can use Pythagorean theorem, right? So remember, if it's horizontal, I can count it. So this would start here at 10. So 10, 20, right? So this distance here is between 10 and 80. So 80 minus 10 is 70. Okay, so that's the distance for Q and R. Okay, everybody, that's our right here. So that's this one. And it says yards. So 70 yards. Okay, and then for our vertical distance, well, this is 50 minus 10. So that's going to be 40. So this is the distance right here. So for P to R is 40 yards. Okay, so now I have 40 and 70. Well, I can use that, everybody, to find the distance for PR. So I can use my Pythagorean theorem. So this is our A value. 70 is our B value, because remember, it's all about that base. No trouble. Okay, so we're going to go squared, B squared, C squared. Okay, so I'm going to substitute it in. So 40 squared plus 70 squared is equal to C squared. I'm going to take the square root of each side. And everybody, you can definitely do where you square them first and then find the square root. But I'm encouraging you to use decimals. So I'm going to go square root again. I'm going to go 40 squared plus 70 squared. Okay. And that gives us our answer of 80. So it's about 80 and 6/10. So our C value, or P to R, this is for our park, is going to be 80. Okay, 5 and up, rounded up. So we're going to leave it the same. So it's 80 and 6/10 yards. So if we want to know the distance around the park, everybody, that means we have to add them all up. So A plus B plus C. So A, B, C. Easy as 1, 2, 3. So we're going to add them up. So 40 plus 70 plus 80. Okay, so that's 40 plus 70 is 110. Plus 80 is 190 and 6/10 yards. So we found our perimeter. Okay, you got this, everybody.